In the early 1960s, scientists still had many questions about how the human body would react in space. No one knew exactly how astronauts would adapt to long periods of weightlessness, and even simple tasks in orbit were still largely unknown. One mission that helped answer many of these questions was the flight of Aurora 7. Aurora 7 was part of Project Mercury, the first American program designed to send astronauts into space and return them safely to Earth. On May 24, 1962, astronaut Scott Carpenter launched aboard the spacecraft and completed 3 orbits around Earth. During the mission, Carpenter carefully observed how both his body and objects behaved in microgravity. In space, the constant pull of gravity that we experience on Earth is greatly reduced, creating a condition where astronauts feel weightless. One important observation involved how objects floated freely inside the spacecraft. Small items, droplets of liquid, and even tiny particles drifted slowly through the cabin instead of falling. These observations helped scientists better understand how fluids and materials behave when gravity is no longer the dominant force. Carpenter also paid close attention to how his own body responded. Scientists were interested in how the inner ear, balance, and coordination would function in space. Because humans evolved on Earth under constant gravity, researchers wanted to know if astronauts might become disoriented or experience motion sickness in orbit. Throughout the mission, Carpenter reported how he felt while performing tasks, operating equipment, and moving around inside the capsule. His observations helped confirm that astronauts could adapt to the unusual environment of microgravity and continue working effectively. Another important part of the mission involved looking out the spacecraft window and observing Earth. Carpenter made detailed notes about cloud formations, ocean patterns, and the curvature of the planet. These observations not only provided scientific information, but also demonstrated that astronauts could conduct useful visual studies from orbit. Although Aurora 7 lasted less than 5 hours, the information gathered during the flight became extremely valuable. The data helped scientists and engineers design better spacecraft systems and prepare astronauts for longer missions. The lessons learned from Aurora 7 later helped support more advanced programs, including Gemini program and eventually Apollo program, which sent humans to the moon. Today, astronauts aboard the International Space Station spend months studying microgravity. But many of the earliest insights into how humans adapt to space began with missions like Aurora 7 and the careful observations made by Scott Carpenter during those first journeys beyond Earth.